Alright, welcome you guys. We're going to be talking about measuring segments right now. Alright, real fast, distances, and they're going to probably, number line is a lot like a ruler. Okay, so there we go. Ugh, that last one was ugly. Okay, so if you're trying to find distances between certain points, okay, just get used to this notation. Let's find point A and D. Okay, so if you wanted to find the distance between A and D, here's a common notation. It's this little absolute value bar, so A and B, and this is used in higher level math too. Okay, it's basically you take the point, you just subtract the two of them, you subtract the lengths. So you just go A minus D, whatever that point value is. And that will get you the distance between. I gotta remember to turn off this caps lock. Okay. Now, whenever you're finding measurings, you can do that. Now, another thing, and this is a postulate that does need to be stated. Okay. Let's say you have an actual point here. Let's say you have a couple of points. And let's get rid of this. Delete. Okay, and let's say we had an actual couple points. Let's say W, Q, and R were these points. Okay, so what this basically you can say is WR is equal to WQ plus QR. Okay, that's pretty simple. A lot of people are going, oh wow, does that really need to be said? When Euclid was coming up with this a long time ago, about 2,000 years, this did need to be said. This did need to be proved, and it was actually able to be proved from some of the axioms. And we'll learn that more about that in Unit 2, what the axioms are. But this helps out because if you have undefined lengths, like let's say this was 3x, okay, and this was 5x minus 2, okay, let's go 2. Alright, and you knew that the total length of WR was equal to 23. You could actually set up an algebraic equation to solve this. So 23 equals 3x plus 5x minus 2. Okay, and you could solve this pretty easily. And then you would add 2 to both sides, so this would become 25 equals 8x. And then you divide both sides by 8, and so 25 over 8 equals x. So you could solve for it that way. So that's why it's really important to go with. Now, some other interesting things too is, and let me see if I can find it in my vast notes on this. So I have a bunch of bookmarks. I want to touch on all of it. Interestingly enough, this measurement idea, and we're just talking about, I mean, this isn't what you're going to be seeing and stuff. Shoot. Okay, so I'm going to do, what I'm looking up is a picture of a coastline, because this actually brings up a great question. Yeah, let's do, yeah, let's go Ireland. Okay, there we go. Alright, now this actually it comes up with fractals. Okay, and this is Northern Ireland, so this is kind of cool. But anyways, fractals, it's the idea of self-symmetry. and they talk about a lot of stuff. And someone tried to measure fractals, and Benoit Mandelbrot, who invented fractals and thus invented the measurements, said, what if you were to measure a coastline? Okay, if you used a 1 mile yardstick, okay, you would get a certain number if you were to measure this coastline. So you go from here to here, from here to there, from there to there, from there to there. Now what if you did a 500 meter yardstick? You would go from here to here, from here to here, from here to here, and you would get a different number because you're using a different, and you just counted the yardsticks, you would be getting a different number. Or if you counted the number of miles, that's fine. What if you used a foot yardstick, from here to here, from here to here, from here to here, from here to here, and you would get a different number than if you used the mile yardstick or the 500 meter. Or what if you use an inch yardstick, from here to here, from there to there, from there to there? And for those of you guys who can't see it at home, I am moving the mouse just probably a couple pixels at a time. Okay, and as you can see, just the measurements get larger and larger based upon the size of the yardstick. So it's kind of cool to see that stuff. Okay, but measuring segments, this is just the basics of it. Just make sure that when you do distance that you treat it as an absolute value, okay? And that will help out tremendously. And then when you see, algebra on your geometry, you're able to set up the algebra problem because you have the algebra postulates that you use in your book. All right, thank you guys. Have a wonderful day, and I'll see you later.